Assalamualaikum and hi everyone. So for CHM260, our team we will present about high performance liquid chromatology, HPLC, perfume and fragrance analysis. So today this is our presenter for this video.
Let's proceed with introduction. Perfume are complex mixture of aromatic compounds that produce distinctive scents because these products are used directly on the body. Fragrance analysis is essential to ensure product quality, safety, and formulation consistency. One of the most effective techniques used for fragrance analysis is high-performance liquid chromatography, or HPLC. HPLC separates compounds based on their interaction with a stationary phase and a liquid mobile phase under high pressure, allowing accurate identification and quantification. In perfume analysis, reverse phase SPLC using a C18 column is commonly applied, particularly for non-volatile and thermally unstable compounds that are not suitable for gas chromatography. Typical fragrance component analyzed includes alcohol, ester, phenols, and fixative, such as linalool, benzyl acetate, eugenol, and coumarin. Overall, HPLC is widely used in the perfume industry for quality control, regulatory compliance, and authentication, ensuring that fragrance products meet safety and performance standards. Okay, next for objective. First, to separate fragrance compound present in the commercial perfume using HPLC. Second, to identify major perfume components based on retention time. Third, to determine the percentage composition of fragrance ingredients. And lastly, to evaluate the formulation quality of the perfume.
Next, we are going to talk about the methodology. For this methodology, we are going to use the HPLC system to analyze the perfume sample. A commercial perfume sample was first diluted with ethanol at 1:10 ratio using a 0.45 micrometer syringe to filter and remove the impurities. So how does this happen? First, 20 microliters of the prepared sample were injected into the HPLC system. Separation was also carried out using a C18 reverse phase column, while detection was used a UV detector at 254 nanometers. For mobile phase, which consists of water and methanol at 7:30 ratio with a flow rate of milliliter per minute. The total runtime for each analysis is 12 minutes, while the 4 peak areas were recorded used for quantitative analysis. This diagram shows that the process of HPLC system to analyze the perfume sample. The mobile phase, which is the mixture of methanol and water, is stored in a solvent and pumped through the system at a constant flow rate. The perfume sample is introduced through the injector and carried out at a C18 column, where separation of fragrance components occurs based on the polarity. As the compounds dilute from the column, they pass through a UV detector at 254 nanometers. This is to detect the aromatic fragrance and produce the chromatogram. Finally, the result of the data will be recorded, which is for the retention times and also the peak areas. This is to analyze the qualitative analysis and quantitative analysis for the perfume sample. Next, we are going to talk about the result. For this result, we obtain is for the HPLC chromatogram of commercial perfume, which have 4 types of peak. The calculation we use is a percentage composition equal to total peak area of compound over total peak area times 100%. So why percentage composition? We use the formula is because the perfume and fragrance were the mixture of many chemical compounds. As we all know that perfume and fragrance has a lot in the world. This is also to compare the relative amount of each component, where peak areas were converted into a percentage. This also helps us to identify the minor and major component in a fragrance. While for the highest peak of a fragrance will be represented as dominant perfume, we use percentage to minimize the effect of instrumental variation. There's also the changes in injection volume and also or detector response. This can help us to get a reliable result for us to interpret. And now we have obtained the result. For the first peak, which is area, we are going to calculate the area. So for the first peak is 0.26, second peak 0.26, third peak 0.25, and also the fourth peak is 0.5. For the total area is 1.27 absorbance unit minutes. Next, for percentage compositions of perfume components. The first peak, the retention time is 2.3 and the composition is 20.5%. Second peak, retention time is 3.8 and the composition is 20.5%. The third peak, 5.6 retention time and the composition is 19.7%. And lastly, the fourth peak is 9.2 retention time and the composition 39.3%. The major components is the fourth peak, which is the highest percentage. Which is using the detection wavelength at 254 nanometers.
Next, I will discuss the HPLC analysis of a commercial perfume sample. The analysis successfully separated the main fragrance component within 12 minutes using a C18 column and UV detection at 254 nanometers. 4 clear and well-separated peaks were observed, showing that the chromatographic conditions were suitable. Linalool eluted first at 2.4 minutes because it interacts weakly with the stationary phase, while benzyl and acetate and eugenol appear at 4.1 and 6.3 minutes, showing moderate retention. Vanillin eluted last at 9.2 minutes due to its higher polarity and stronger interaction. From the peak areas, vanillin was the most abundant compound, followed by linalool, benzoacetate, and eugenol. The high vanillin context explains its role in giving the perfume a long-lasting and sweet base note. Overall, the clear peaks and stable baseline show good sample quality. This proves that HPLC is an effective method for analyzing perfume components.
So to conclude, the HPLC method can successfully separate and analyze the major fragrance compound present in the commercial perfume sample. This is because by using a C18 reverse phase column and UV detection at 254 nanometer for fragrance components like linalool, benzyl acetate, eugenol, and vanillin were clearly resolved within a 12-minute runtime. Based on quantitative analysis, by peak area normalization showed that vanillin was the most abundant compound, followed by linalool, benzyl acetate, and eugenol. This is because the clear peak separation and stable baseline indicate a good formulation, quality, and effective chromatographic condition. Overall, this study demonstrates that HPLC is a reliable and efficient technique for the qualitative and quantitative of perfume and fragrance product, making it suitable for quality control and formulation evaluation in the fragrance industry.
This is our references for our video presentation. That's all for our video presentation. Thank you for watching.